I'm Nimesh Bhagat. I lead product management for Snowpark. With me, I have Doris Lee. Doris leads our PyData initiatives. She was previously CEO, co-founder of open source company Modern. Today, how many data engineers over here? Just raise of hands. This is a session for you all. I'll give you a quick overview on pipelines at Snowflake. Then we'll have lots of announcements on SQL pipelines and Python pipelines, along with demos. So let's get started. Let's talk about pipelines at Snowflake. Many of you who said you're data engineers, we talked to many of you. What I say is you're the unsung heroes. When your organization, your business has amazing outcomes with business and AI, it's because of the data you produce. You are the ones who are transforming that data, getting it at the right time, to the right audience, right quality, most importantly, so that these outcomes can be met. But we hear from many of you, you're overwhelmed. Many of you are burnt out. With AI demands growing, this is only going to get worse. I categorize this, as you see in this chart, 3 types of complexities and burdens you handle. The first is infrastructure management. You have to bring your infrastructure up and running, maintain it. It's a never-ending thing. Second, it's platform complexity. You're trying to standardize a platform for your SQL developers, your Python developers, your Pandas developers, your Spark developers, through the various skill sets. Then the tools, orchestration, monitoring, stitching all of this together adds complexity. And third, with all your remaining time, you're just firefighting, you're reactive firefighting. The pipeline is delayed, cost is higher, a happened, the query needs to be optimized. And what does this do to you? No time to do creative, innovative, meaningful, impactful work. What if you could reclaim that time? At Snowflake, we pride ourselves with simplicity. Our core mission over here is, can we simplify data engineering for every persona, every workload which you have? We do this by what we call zero-ops data engineering. Zero-ops data engineering means you're empowering data teams to focus purely on building high-value data and pipelines. We do this by automating and abstracting over the underlying infrastructure management and operational toil. This isn't just a vision, it's a reality. Thousands of customers use our data engineering products, build pipelines every day. 3 examples over here. TravelPass, migrated off Databricks, saved 65% in cost. 350% efficiency improved using dynamic tables. Illumina, over here, it does innovation in genomics on Iceberg table. We ensure there's limitless interoperability. You can work on Iceberg, multiple packages. You can bring your ecosystem to us. And then third, Whoop is turbocharged this AI, and it made it 3x faster by building forecasting models on Snowflake. You can learn more and many such stories across these sessions on the summit. So we simplify your data engineering by providing an end-to-end solution, starting with data integration, pipelines, and then to allow you to monitor all of this through a single surface. Plus, you can work in your favorite environment. Right now, we are focused on pipelines, which is how do you transform your data across different languages and how do you orchestrate it. You can learn more about other areas on this session. Now, at Snowflake, we understand your toolkit is diverse. That's why we are committed to not only building an end-to-end simple solution, but also ensuring you can use your favorite tools across the entire data lifecycle, orchestration, pipelines, and monitoring. We work closely with all these vendors and plenty more. I encourage you to visit all of them on the booths over here, which are present today. So now let's dive into SQL pipelines. SQL developers love Snowflake. When we talk to them, hey, what do you like the most next? We hear dbt. dbt is an open source tool. Customers love it because it brought the software engineering best practices on tool pipelines. You could create your data models, You could do integrated quality testing of your pipelines and data. And you can do your GitHub actions on it as well, like any other software developer. But we heard from our customers 3 things. We heard new teams find it hard to onboard. There is onboarding and learning curve. There's burden of maintaining 2 systems or multiple systems. And third, when things go wrong, you have to correlate logs across multiple of them and know where the problem is. This is a quick overview of how dbt works today for customers. We are changing all of this, simplifying this further by announcing dbt projects, which we did over the summit. What is dbt projects? With dbt projects right through inside Snowflake console, you can build, test, deploy, schedule, and monitor your dbt pipelines. This way, you consolidate all the systems into a single system, and your new teams can onboard very seamlessly. This is all available right now through Snowflake Workspaces. So your developers can use the modern way of doing development, which is file-based, modern-based development on a single editor through Snowflake Workspaces. We have been working closely with our design partners with dbt. They all love it. They say it's intuitive, it's fast, it's reliable. Quote here from Chris at Interworks summarizes it well. This is enough of talking. What you would love to see is a demo. How does this do simplicity? Snowflake simplicity and dbt simplicity comes together, and plenty more. I'll hand it over to Doris.
Thanks, Nimesh. OK, so in our demo today, we'll be taking a look at dbt projects. In this demo today, we'll be working with the Tasty Bites dataset, which is a global food truck network across different cities, countries, and so on. And we'll put on the hat of a SQL data engineer who is trying to work with these raw datasets, transform it into business-ready datasets that our BI analyst is ready to use for analysis. So here's a look at the data model that we'll be working with today. For the raw, so we'll be starting with raw customer data and point of sale systems. We'll be doing some transformations, aggregation, joins, and so forth. And finally, creating that as the data in our marts layer. So those are the 3 tables that we'll have in our marts layer. And all of this will be developed, orchestrated, and monitored using our dbt projects. So enough talking. I'm going to switch over to our demo. Let's see. Are we able to see the screen? Yep. Awesome. So here, what I have, let me zoom that in a little bit. Here, what I have opened up is our new Workspaces IDE. This allows you to kind of run and manage your dbt projects. One of the things I want to call out here is on the left-hand side here, you could see that I have my Objects Explorer. That allows me to take a look at all the databases and schemas and tables that I have in Snowflake. So in this case, I'm working with my Tasty Bites 101 data. I have 8 tables that is listed here. These are the tables that I'm going to be working with. Now, if I hide my Objects Explorer, on the left-hand side here, I see a bunch of files that is associated with my dbt projects. Now, this is really useful because I can take a look at all the different files, the SQL file, the Python files, and so on. But I can also take a look at some of the YAML files that is used to define my dbt projects. So you could see here that in the profiles pane, I have 2 profiles that are defined. I have my dev profile and my prod profile, prod for production. And each of these profiles have account, user, role, database schema that's associated with it for my dev and production profiles. And so once I've been able to define that in my profiles.yaml, you can see the profile, the dev and the prod profile in my in the top hand bar here. I can switch between dev and prod. I can also run a list of dbt commands. So some of the, if you're familiar with dbt, some of the common commands that you might run is dbt deps for dependencies that pulls in all the packages that you need and updates the dependencies. You might also be familiar with dbt test, which is useful for validating and testing your data model before you put it into production so that you can spot any issues before things go in production. And then we also have dbt compile. I'll show you what the dbt compile command does. So let's say here I have a dbt model. Let me just hide that on the left-hand side so we could see that more clearly. So here I have a data model that's essentially a query for computing customer loyalty metrics. And you could see that here I have Jinja references to the tables. But when I compile my SQL query using dbt projects, I can take a look at the compiled query, and you can see that this has the fully specified path to the tables that I'm working with, and same with this other reference. And so after you compile your dbt projects with these fully specified query, let me just make sure I could run this. It's a little bit too zoomed in. Okay, so I can run this query and then view the result of the query that's been run here. So here I could see, hey, this is a fully executable SQL query for my data model. This is the output of that query. Okay, so I'm going to close that. And then the last thing that I want to do is I've been able to test compile my project. I'm going to do dbt run. Now, dbt run runs through my data model. You can either run through all the models in your dbt project. For the purpose of this demo here, I'm just running a single model, which is my customer loyalty metrics. And you could see that this project is being run. While that's going on right now, I want to show you how you can view your DAG. So this is essentially the data flow graph associated with this model. So you can see that when I click on Show in DAG, this model is highlighted. And you could also see the data flow all the way from the raw layer to staging layer to the marts layer. So this, you could recall from the slides, looks very similar to what we had in the slides. And this is automatically being generated when we do the dbt compile so that you could get a sense of how the data flows between the different parts of this workflow. Okay, so hopefully that has finished running. Yes, so we see that the dbt projects the dbt run has completed, and we've been able to run this data model. One of the things I forgot to call out here is we have this sources.yaml, which shows you all the data validation and tests that we run through. And so if you were to run dbt test here, it will actually go through all the tests here. There's about 53 tests that is used to validate, things like, hey, maybe I don't want null values in my columns. I want my values to be unique, or even min-max value, like the data should fall under certain ranges and things like that. So that's a very easy way to quickly test and validate your model. Okay, so now we've been able to run our dbt, run and test and compile our dbt project. We're ready to deploy that in production. And to deploy our dbt project, we can click on this deploy button. We can select the location for this deployment. And then also we could either create a dbt project. In this case, I've already created one. So when I deploy a dbt object, that becomes a Snowflake object that I can then schedule, create a task around. I can even execute through the Snowflake CLI to work with this dbt projects. And so you could see that here if I want to create a schedule. Let's say I want to create a schedule that runs daily. I can specify the frequency. And then I can also say, hey, what is the command that I want to run on the daily schedule, and specify the profile that is used to run this. So I'm actually going to call that daily prod. I'm going to create that schedule. And what that will do is that will schedule my job on a daily basis. So now if you go into view schedules, you can see all the jobs that I have associated with this dbt project. Okay. So now I've been able to both schedule and run this dbt project. The last step is kind of seeing how your dbt project pipeline execution has been doing. So I can go under transformation, dbt projects, and see that there has been 74 executions associated with my dbt project. I can click onto any one of these. and see all these successful runs and the history of that, I'm just going to click into any one of these. And one of the things that we've added to DBT project is open telemetry support, so that if I go under this query telemetry tab, I can see all the spans that are associated with each of the data models that have been executed. And this is where you could spot bottlenecks, see any parallelism, and really understand and spot any issues related to your code. So what I've just opened up here is for this particular span, I can look at all of the logs that are associated with my query. Okay, so I'm going to switch back to... Yes. Okay. So to wrap up, we saw how easy it is to work with our DBT projects by being able to test, maintain, develop, and monitor your pipelines all in one place. So at Snowflake, one of the things that we care a lot about is meeting developers where they are. And we're seeing a growing number of Python developers, customers telling us that they're starting to build Python data pipelines for their data engineering work. And so what we've introduced is Pandas on Snowflake. Pandas on Snowflake is a simple, unified interface for working with your Snowflake data using your familiar Pandas API. It allows you to stay connected to your Snowflake views, tables, dynamic tables, Iceberg, and so on, and even bringing in files from things like CSV, Parquet, Excel files into Snowflake. We also allow you to build pipelines from prototype to production, supporting data, building data pipelines at all scale. And finally, we also support flexible data transformation with your familiar Pandas API. Okay, so we're going to switch to the next demo that we'll be seeing here. Okay, so here I have my Snowflake notebooks open. In this notebook example, I'll be working with an iceberg table. And just to show you kind of what that iceberg table looks like, this is the definition of the iceberg table. The name of the iceberg table is Restaurant Reviews. Iceberg, it has a Snowflake catalog, this external volume, and base location. You can see that with Pandas on Snowflake, we make it super easy for you to leverage this capability within notebooks. So when you do something like pd.read Snowflake, this allows you to read directly to your iceberg table or Snowflake table into a DF, which is a data frame variable that you can start working with. And from this point on, you can work with your familiar Pandas API. You know, I can do things like print out the data frame and inspect my data. I could take a look at all the different columns that are there. Let's see. Yeah, so I could take a look at my data here. I can also do things like df.info. And so whenever I'm loading in a new data and looking at it for the first time, I often want to take a look at what the data looks like, taking a look at each of the columns. So df.info or df.describe is really useful for doing that. And that allows you to spot things like, hey, this source column is all null values. So maybe this is something that we can clean up in our data. So I can drop this source column. And then you could see as I print out this data frame, this source column with all the null values has been dropped. So this is a very easy way for you to quickly clean up your data and inspect what's going on. One of the columns that I'm interested in here is a column called primary cities. And I'm going to do a value counts on it, which essentially computes the number of reviews that is associated with each of the cities. And you can see how easy it is to do this with the Pandas API. It's just a single line of code. Now that I've been able to profile and clean up my data, I'm ready to do some feature engineering on this data. So in this case, we were looking at the primary cities table, and then you could see all of the unique values that is associated with primary cities. There's about 29 or so cities. Now that's a lot of different cities to work with, and in order to perform my analysis, I want a smaller set of geographic regions that I can work with. And I don't want to specify the mapping one by one. That's a lot of work, lots of typing. And so I'm actually going to use the Snowflake Cortex LLM function to classify each of the cities into geographic regions. So that's exactly what I'm doing here. I'm taking my city mapping data frame DF, doing an apply on it. And so for each of the rows in the apply, I'm going to call this classified text Snowflake's Cortex LLM function to classify it into one of these categories. And once I've been able to do that, you could see that on the left-hand side here, I have all the cities, Rio being mapped to Americas, Barcelona in Europe, Cape Town in Africa, and so on. So just with that, I'm able to incorporate LLM functions directly in my Pandas feature engineering workflows. And so finally, I'm going to take that mapping dictionary and then apply that mapping to the primary cities column so that I can get this region information. So what we should expect in our featured data frame after all of these transformations is that we should see an additional column with regions that is one of the 4 categories. So if we scroll to the right and see, we do indeed see that new feature column region being added to the data frame. And then finally, you can't work with Pandas without showing some visualization. So I'm going to show a cool use case of how you can do, plot an Altair visualization, looking at now grouping by our new region information and then the number of reviews that are associated with each of the regions. Now that we have the final feature data frame, again, this is what a quick inspection of what the feature data frame looks like. Okay, so I've been able to do all my data transformation, my feature engineering, and so on. And so I'm ready to save that as an iceberg table. So I can do that very easily with a single line, my feature df.to iceberg. I give it an additional sort of name, and then I pass in the iceberg config. And just like that, I've been able to create my iceberg table. Now, what if we wanted to create a dynamic table because our source data from the food trucks is constantly, streaming in new reviews and so on? So in order to create a dynamic table, I can use the featuredf.to dynamic table command. I give it a name. I specify the lag. For the purpose of this demo, I will just specify a lag of 1 minute. It means that my data is, the dynamic table keeps it, the data freshness is at 1 minute. I also specify the refresh mode as incremental, and we'll take a look at what this looks like. But before we do that, I want to show you what that dynamic table, let me refresh the page. I want to show you what that dynamic table looks like. So this is the dynamic table that has been created. If you take a look at the refresh history, you could see that when this dynamic table is created, there's 124,000 rows that has been created. Now, this is the first time that I've ran that pipeline. Now, what if I insert 10 rows, like into the source table? So recall this insert into this table. This is the original table at the very beginning of our pipeline. I'm essentially inserting 10 new rows into this data set to simulate the fact that, hey, new reviews are coming into my source table, and what happens when new data arrives. So if I go back to my dynamic table, I can refresh this page. I now see that there has been 10 rows that has been changed. Dynamic table is intelligently enough to say, hey, I want to update just these 10 rows incrementally, instead of saying, hey, I'm going to run a full refresh on the entire table, which would have ran through 124,000 rows. So this is the magic of dynamic table, being able to maintain that incremental refreshing as your new data comes in, which is a really easy way of automating your pipeline orchestration. And so just to show you that the feature engineering pipeline actually ran through. I'm going to do a select from query here, and you should be able to see that for these 10 new rows that has been added, this new region feature has been created, which shows that the feature engineering pipeline has indeed completed. Okay, so I'm going to switch back to... Okay, so one of the things that Nimesh talked about earlier in the talk is how coming back to this idea of like how data engineers have all of these burdens with operationalizing their pipelines. We've seen how doing data engineering in Snowflake removes a lot of these burdens for data engineering teams and unlocks downstream use cases. And so, as you could see, with these advancements that we talked about today with SQL and Python pipelines, we're helping you say goodbye to all this complexity through zero-ops data engineering, limitless interoperability, and empowering you to turbocharge your AI initiatives. So the future for many organizations will be defined by AI. And the quality of that AI hinges on the data that you feed it with. So in order for your AI initiatives to be successful, you need the right data foundations that ensures that the right data is arriving at the right time to the highest possible quality. And we're incredibly excited to see what you will build with these new capabilities.